Let's say that hypothetically, you're sick of logarithms. Well, this is the only video out of however many videos in a row. This is the only video that is not going to have anything to do with logarithms. I'm pretty sure. I don't think I'm going to mention I don't think I will write down a logarithm at any point in this video. So take a little logarithm vacation. So let's remember something that we talked about a long time ago in chapter 3. One-to-one functions. If a function is one-to-one, then, oh, hold on. If two functions are one-to-one and equal, that whole sentence was messed up. If two functions are one-to-one and equal, then their insides must be equal. Let's unpack this statement real quick. So what this means is if I have the square root of x equal to the square root of y, these are two functions, the square root functions. These two square root functions are equal. Then x has to equal y because the square root function, you remember what the square root function looks like? Square root function is one-to-one. It passes the horizontal line test. But if I have something like this, x may or may not be y. And in fact, we know that x is equal to plus or minus y. Because this is not one-to-one, right? Parabolas are not one-to-one. Parabolas fail the horizontal line test. Now let's see, where am I going with this, Jason? You're in chapter 6. Why are you talking about one-to-one functions? Well, you know what other function is one-to-one? Exponential functions and logarithms. I didn't write down a logarithm. Exponential functions are also one-to-one. And that's how we're going to start today. We're going to solve some exponential equations using this one-to-one property. If two exponential equations have the same base, their exponents must be the same. Example 1. Solve. No logarithms, not even a mention of logarithms after the 5 mentions I've already done. Starting now, I will not say the word logarithm for the rest of this video. 2 to the x equals 8. Now in the next video, we'll solve this using the inverse function of exponentials. But in this video, we're going to solve it by writing these as exponents. If two exponential functions have the same base, then their insides are equal. Well, they don't have the same base, but we can make them have the same base, right? What's that right-hand side equal to? 8 is 2 cubed. And I know that most people can probably see, okay, x has to be 3. This is introducing the method, okay? Because sometimes it's going to be more complicated, and that's what my part B's are for. All right? So 2 to the x equals 2 cubed. So the exponents have to equal each other, and x is 3. Can check our answer. Plug in 3. And is this true? Yep. Great. Let's get into this trickier ones. We'll get a little trickier and then a little trickier, and then we're just going to go down the deep end and we're going to get some wild problems, all right? 2 to the x plus 5 equals 4. Let's use the same exact logic. If two exponents have the same base, if two exponential functions have the same base, their exponents have to be the same. So let's rewrite the right-hand side again. 4 is 2 squared. So, because the exponential functions are one-to-one, those exponents, the inside of these functions, have to be equal. And now we can solve this equation, no problem. X is -3. And if we check our answer with a calculator, you should indeed, that exponent becomes +2. 2 squared is indeed equal to 4. Let's do part C. 3 to the 2x plus 1 times 3 to the x equals 81. Now there's a whole lot of cleaning that needs to be done. Right, we eventually want 3 to some exponent equals 3 to some other exponent. There's a lot to do before we get it in this form. We have to clean up the left-hand side, we have to clean up the right-hand side. But just like cleaning in real life, it doesn't help to talk about it, we just got to get started. So we have 2 exponential functions multiplied. We can do that by adding their exponents together. Right? This is using the property a to the b times a to the c is a to the b plus c. Same base means add those exponents together. And the right-hand side, that's 3 to what power? 3, 9, 9 is 3 squared, multiplied by 3 again, that's 3 cubed, 27. 81 is 3 to the 4th power. Now you can either simplify these exponents, or just say they're equal. 2x plus 1 plus x equals 4. Well, subtract 1 from each side and combine like terms. 2x plus 1x, that's 3x's. 4 minus 1, that's 3. Divide both sides by 3, x is equal to 1. Let's check our answer. Is 3 to the 2 times 1 plus 1 times 3 to the first exponent, is that equal to 3 to the 4th? That's 3 cubed times 3. That's 3 to the 4th. Yep, you betcha. Just like that. And these problems work as long as we have the same base. If we ever don't have the same base, or we can't make it have the same base, then we're going to have to use inverse functions of exponentials, whatever those are called. We're going to have to use what we'll talk about in the next video, inverse functions of exponentials, to undo it. I'm keeping my word. Let's do part D. All right, 1 over 64 raised to the 2n power times 4 equals 2 to the 6. All right, we're really going wild now. This is the last one of this video. All right, and even something like this is usually easier with that other method, with those inverse functions. But everything here is in base 2. Has a base of 2. 64, that's 2 to some exponent. 4, yep. 2, yep. So let's get rewriting. What is 64? 1 over 64 in terms of 2. Well, I know it has a negative exponent because the 64 is in the denominator. 2, 4. Let's keep doubling. 2 to the first power, 2 to the second power is 4, 8, 16, 32, 64. You can also use a calculator. 4, let's write that with a base of 2. Let's keep simplifying. How do we simplify this? It's an exponential function raised to an exponent. We multiply those 2 exponents together. Because again, just like in the last one, we want 2 raised to some exponent equals 2 raised to some other exponent. Now we have 2 exponential functions of the same base. Add those exponents together. They're not like terms, so it has to just be -12n plus 2. And now we have 2 exponential functions with the same base, so their insides must be the same. All right. We can solve this, no problem. Subtract 2 from both sides. That'll give us negative 12n equals 4. Divide both sides by negative 12. And you should get that n is negative 4/12, which is negative 1/3. We can check our answer. It's going to be a little harder this time. So when I check my answer this time, let's look at each side by itself. The left-hand side of this equation is 1/64 to the 2 times negative 1/3, that's negative 2/3, times 4. So the negative is a reciprocal, becomes 64 to the 2/3. Cubed root of 64 is 4. This is 4 cubed. 4, 16, 64. There we go. What's the right-hand side? 2 to the 6th power. We already said that's 64. Great. Left-hand side and right-hand side are the same. Our answer checks out. And that's this video. Good luck. In the next video, we're going to use not this property, but we're going to use whatever the inverse function is for an exponential function. And hopefully by now in chapter 6, you know what the inverse function of an exponential is. How do we undo exponentials? Stay tuned to find out.